Yes, the National Electrical Code, or NEC, provides allowances for installing an emergency generator with automatic transfer switches in the configuration described. Specifically, Article 230.82 addresses equipment permitted on the supply side of the service disconnect. The NEC permits systems such as emergency systems, fire alarm systems, fire pumps, legally required standby power systems, and sprinkler systems to be connected ahead of the normal service disconnecting means, provided these systems are equipped with a separate disconnecting means and overcurrent protection. In this scenario, the emergency generator serves as a backup power source for the facility. The proposed installation involves connecting the generator ahead of the normal service disconnecting means, which in this case are the transformers feeding the A and B buses. The automatic transfer switches act as a separate disconnecting means for the generator system. The circuit breakers within the automatic transfer switches provide the necessary overcurrent protection for the generator and its associated circuits. Since the generator system includes both the separate disconnecting means in the form of the automatic transfer switches and overcurrent protection via the circuit breakers in those switches, the installation is permissible under the NEC. The critical aspect is ensuring that the automatic transfer switches are appropriately sized for the load they will carry and that the overcurrent protection is coordinated to protect the generator, the transfer switches, and the downstream distribution panels. When installing emergency systems, several sections of the NEC come into play beyond Article 230.82. These include Article 700, which covers emergency systems in general, Article 701, which addresses legally required standby systems, and Article 702, which pertains to optional standby systems. The selection of the appropriate article depends on the specific requirements and categorization of the backup power system being installed. Article 700 is typically applied to systems that are legally required to operate when the normal power supply fails and are intended to supply illumination and power essential for safety to human life. These systems are often found in hospitals, emergency treatment facilities, fire stations, and other critical infrastructure. Article 701 covers legally required standby systems which are intended to supply power to vital systems such as heating, refrigeration, communications, and industrial processes that could create hazards or hamper rescue or firefighting operations if interrupted. Article 702 applies to optional standby systems which are installed to provide power to non-essential loads and are not legally required for safety or operation. It is important to determine which of these articles applies to the specific installation to ensure compliance with all relevant requirements. For an emergency generator installation as described, Article 700 or 701 would likely be the most relevant, depending on the nature of the loads being backed up. In addition to the general requirements outlined in Articles 700, 701, and 702, other sections of the NEC provide specific guidance on the installation and wiring of emergency power systems. These include Article 445, which covers generators, Article 480, which covers storage batteries, and Article 700.12, which addresses wiring requirements for emergency circuits. Article 445 provides requirements for the installation, overcurrent protection, and disconnecting means for generators. It specifies the type and size of conductors, the rating of overcurrent devices, and the location and accessibility of disconnecting means. Article 480 covers the installation and maintenance of storage batteries used in emergency power systems. It includes requirements for battery construction, ventilation, charging, and disconnecting means. Article 700.12 outlines the wiring requirements for emergency circuits, including the separation of emergency circuits from normal power circuits, the use of fire-rated cable assemblies, and the installation of emergency lighting and power outlets. The NEC also addresses the transfer equipment used to switch between normal power and emergency power. Article 700.6 provides requirements for transfer equipment, including its rating, construction, and operation. It requires that transfer equipment be suitable for the intended use and be designed to prevent the inadvertent interconnection of normal and emergency power sources. The automatic transfer switches used in the described installation must comply with these requirements. Furthermore, the NEC specifies requirements for testing and maintenance of emergency power systems. Article 700.3 outlines the requirements for periodic testing of emergency systems to ensure that they are capable of supplying power during a power outage. It requires that emergency systems be tested under load conditions and that records of testing be maintained. The NEC also addresses the coordination of overcurrent protection in emergency power systems. Article 700.27 requires that overcurrent devices in emergency systems be selectively coordinated to minimize the extent of a power outage in the event of a fault. Selective coordination means that the overcurrent device closest to the fault should trip first, while upstream devices remain closed to maintain power to other essential loads. In addition to the NEC requirements, local codes and regulations may also apply to emergency generator installations. It is important to consult with local authorities and obtain the necessary permits before beginning any installation work. Some jurisdictions may have specific requirements for generator sizing, emissions, noise levels, and fuel storage. These requirements may vary depending on the location and the type of facility being served. To ensure compliance with all applicable codes and regulations, it is recommended to work with a qualified electrical contractor who is familiar with emergency power systems and local requirements. A qualified contractor can help design and install a system that meets the specific needs of the facility while also complying with all applicable codes and regulations. The contractor can also provide ongoing maintenance and testing to ensure that the system remains in good working order. In the specific scenario described, the installation of the emergency generator with automatic transfer switches appears to be permissible under the NEC, provided that the system is designed and installed in accordance with all applicable requirements. This includes providing separate disconnecting means and overcurrent protection for the generator, complying with the wiring requirements for emergency circuits, using approved transfer equipment, and coordinating overcurrent protection to ensure selective coordination. Furthermore, it is important to comply with all local codes and regulations and to work with a qualified electrical contractor to ensure a safe and reliable installation. When considering the relocation of transformers to accommodate the installation of automatic transfer switches, several factors should be taken into account. These include the physical space requirements for the new location, the accessibility of the transformers for maintenance and repair, and the potential impact on other electrical equipment or systems. The new location should provide adequate ventilation and protection from the elements, and the transformers should be installed in accordance with manufacturer's instructions and all applicable codes and regulations. The relocation of transformers may also require modifications to the building's electrical service entrance and distribution system. These modifications should be carefully planned and executed to ensure that the electrical system continues to operate safely and reliably. It is important to consult with a qualified electrical engineer and contractor to assess the feasibility and cost of relocating the transformers and to develop a detailed plan for the work. In addition to the technical aspects of the installation, it is also important to consider the administrative requirements. This includes obtaining the necessary permits from local authorities, notifying the utility company of the planned work, and coordinating with other trades involved in the project. Proper planning and communication can help to ensure that the installation proceeds smoothly and without delays. The installation of an emergency generator with automatic transfer switches is a complex project that requires careful planning, design, and execution. By following the requirements of the NEC and local codes and regulations, and by working with qualified professionals, it is possible to install a safe and reliable system that provides backup power during a power outage. The benefits of such a system include increased safety, reduced downtime, and improved business continuity. To elaborate on Article 230.82, it is crucial to understand the specific language used and its implications. The phrase equipment permitted on the supply side of the service disconnect refers to equipment that can be connected to the electrical service before the main service disconnecting means. This is a critical point because it allows certain essential systems to remain operational even if the main service disconnect is opened. The NEC specifically lists examples of such equipment, including systems such as emergency, fire alarms, fire pumps, standby power, and sprinkler systems. This list is not exhaustive, but provides a clear indication of the types of systems that are permitted to be connected ahead of the service disconnect. The key condition for allowing these connections is that they must be provided with a separate disconnecting means and overcurrent protection. This requirement ensures that the essential systems can be isolated from the rest of the electrical system in case of a fault or maintenance, and that they are protected from overcurrent conditions. In the context of the described scenario, the emergency generator is being installed as a backup power source, which falls under the category of standby power systems. Therefore, it is permissible to connect the generator ahead of the normal service disconnecting means, provided that the automatic transfer switches act as the separate disconnecting means and the circuit breakers within the transfer switches provide the necessary overcurrent protection. The automatic transfer switches play a crucial role in this installation. They are designed to automatically switch the load from the normal power source to the emergency generator in the event of a power outage. This ensures that the essential systems continue to operate without interruption. The transfer switches must be properly sized and rated for the load they will carry, and they must be installed in accordance with the manufacturer's instructions and all applicable codes and regulations. The overcurrent protection provided by the circuit breakers within the transfer switches is also essential. These breakers are designed to protect the generator, the transfer switches, and the downstream distribution panels from overcurrent conditions such as short circuits or overloads. The breakers must be properly sized and coordinated to ensure that they trip in the correct sequence, minimizing the extent of a power outage in the event of a fault. In addition to the requirements of Article 230.82, other sections of the NEC may also apply to this installation. These include Article 445, which covers generators, Article 700, which covers emergency systems, and Article 701, which covers legally required standby systems. It is important to consult these articles to ensure that the installation complies with all applicable requirements. Article 445 provides requirements for the installation, overcurrent protection, and disconnecting means for generators. It specifies the type and size of conductors, the rating of overcurrent devices, and the location and accessibility of disconnecting means. Article 700 provides requirements for emergency systems, including the separation of emergency circuits from normal power circuits, the use of fire-rated cable assemblies, and the installation of emergency lighting and power outlets. Article 701 provides requirements for legally required standby systems, which are systems that are required by law to operate during a power outage. These systems may include fire pumps, ventilation systems, and other essential equipment. In the specific scenario described, the installation of the emergency generator with automatic transfer switches appears to be permissible under the NEC, provided that the system is designed and installed in accordance with all applicable requirements. This includes providing separate disconnecting means and overcurrent protection for the generator, complying with the wiring requirements for emergency circuits, using approved transfer equipment, and coordinating overcurrent protection to ensure selective coordination. Furthermore, it is important to comply with all local codes and regulations and to work with a qualified electrical contractor to ensure a safe and reliable installation. It is also important to consider the maintenance and testing requirements for emergency power systems. The NEC requires that emergency systems be tested periodically to ensure that they are capable of supplying power during a power outage. The testing should be conducted under load conditions and the results should be documented. Regular maintenance is also essential to ensure that the system remains in good working order. This may include inspecting and cleaning the generator, checking the battery voltage, and testing the transfer switches. By following a regular maintenance schedule, it is possible to ensure that the emergency power system is ready to operate when needed. The size of the generator is also an important consideration. The generator must be sized to handle the load that it will be required to carry during a power outage. This includes not only the essential loads, such as lighting and life safety systems, but also any other loads that are necessary for the operation of the facility. It is important to calculate the total load and select a generator that is capable of supplying that load. The generator should also be sized to allow for future expansion. The fuel supply for the generator is another important consideration. The generator must have an adequate fuel supply to operate for the duration of a power outage. The fuel supply should be stored in a safe and secure location and should be protected from the elements. It is also important to have a plan for refueling the generator in the event of a prolonged power outage. The location of the generator is also important. The generator should be located in a well-ventilated area and should be protected from flooding and other hazards. The generator should also be located in an area that is accessible for maintenance and repair. The noise level of the generator is also a consideration. Generators can be noisy, so it is important to select a generator that meets the noise requirements of the local jurisdiction. In some cases, it may be necessary to install sound attenuation measures to reduce the noise level. The emissions from the generator are also a consideration. Generators can emit pollutants, so it is important to select a generator that meets the emissions requirements of the local jurisdiction. In some cases, it may be necessary to install emissions control devices to reduce the emissions. The cost of the generator is also a consideration. Generators can be expensive, so it is important to shop around and compare prices. It is also important to consider the cost of installation, maintenance, and fuel. By carefully considering all of these factors, it is possible to select an emergency generator that meets the specific needs of the facility and provides reliable backup power during a power outage. The NEC provides a framework for the safe and reliable installation of emergency power systems. By following the requirements of the NEC and working with qualified professionals, it is possible to ensure that the emergency power system is ready to operate when needed. Always consult with a qualified electrical engineer to verify the calculations.